So this one, the structure pop quiz, as we want to determine the student exercise by lifting a weight attached to a machine. The machine has a cable as shown in the photograph. The cable passes through a handle and it's connected to a weight. There is a tension T in the cable. The angle between the two sides is 60 as shown in the diagram. A person keeps the cable stationary by applying a force of 121 Newton. Determine the magnitude of a tension using a scaled vector diagram. So when a person is applying a force, so he's pulling it, and that force is balanced by the resultant of the two tensions. Because this is, if this is T, this is also T, and in the question the angle between them is, total angle is 60, so each angle will be 30 degrees. So this 121 Newton is actually balances with R. So we know the resultant of the two tension should be 121. That we know. Now we want the tension in the cables. So how we can work out the tension in the cables? By a scale diagram, scale vector diagram. So what we will do first, we select the scale. We said like 1 centimeters equals to 10 Newton. So 121 Newton will be 12.1 centimeter. Or you can also reduce the size of the scale. If you select, let's say 1 centimeter is 20 Newtons. So 121 divided by 20, that will be 6.05. So in that case, if it is 121 Newton, you will get as 6.05 centimeter, or about 6 centimeter you will get. So you can reduce the scale, because to draw a 10 centimeter line on the exam, you won't have sufficient space if a half of the space is available. If full page is available, then you can draw that. So now what we are doing, we know the resultant should, the length of the resultant is 6, or if you select 1 centimeter is 10. So we selected this is 6 centimeter according to the position. Now, so we want a resultant. So if you use a parallelogram method, in a parallelogram method, you start both vectors from a same point. So, and each should have an angle, the same angle. Why each should have the same angle? Because they are same magnitudes. The T is there, so they should also have the same angle. So the resultant will be actually between the two. So this angle will be 30 degrees. This angle will also be 30 degrees. And then you complete a parallelogram. Once you complete a parallelogram, you can measure this length by the scale, the ruler, and what length you will get, you will convert according to your original scale. That's one way. The second method, you can use the same triangle method for this, that you know the resultant, which is 121 according to the scale. So you can draw first T. First, you can draw T at an angle of 30 to the resultant. And then another T, what is the total angle between them? Total angle is 60. So you place your protractor here and mark 60 degree and draw a line. So this angle will be 60 here and this angle was 30. And it should meet here. So this give an indication, or this give an idea that the value of a T. So you just again measure the length using a scale, measure the length, and that will be equals to the tension in any one of the string, and that will be same. Is it clear? Because the total angle between the two tension is 60. So if I'm drawing this T here, so this angle will also be 60 degrees. That's how this angle is 60 degrees. In part B, the cable is attached to a 150 Newton load. Each time a person pulls the handle, the weight moves vertically up to a distance of 0.25 meters. The weight returns to its original position when the handle is released. A person exercises by pulling and releasing the handle. They do this 90 times in 120 seconds. The exercise machine displays the average power of a person as 35 watt. Deduce whether the power displayed by the machine is consistent with this data. So power is what? Power is work done in a unit time. And what is work? Work is force into distance divided by time. So we just have to calculate the power and we have to show that it is consistent with the result. So how much work is done? Because he's lifting a 150 Newton load to a distance of 0.25. And what about the time? Because he's doing 90 times in 120 seconds. So for one time, like to lift it up, how much will be there? So it will be 120 divided, the time to lift once, that will be 120 divided by 90. So we'll know like how much time it will take to lift once. The distance moved was 0.25 and the load which was lifted is 150 newtons. What's the answer here for the power? 150 times 0.25 divided by the ratio of 120 and 90. Okay, that is 28.1. So 28.1 watts. So 28.1, 28.125 or 28.1, is it consistent with 35? There's a large difference. The percentage difference is high. So it means it is inconsistent. Like a machine does not show a average power correctly. Question 4, any doubt? Question 4, any doubt? For A. The resistivity paper is a paper covered with a thin layer of a carbon. As you can see here, the distance between the ends of a piece of resistivity paper is 12 centimeter and the resistivity of a paper is 4.2 centimeter. The resistivity paper is 4.2 centimeter wide. The resistance between the end is resistance between the end of a resistivity paper is 8.8. Calculate the thickness of a layer of a carbon. Like we need this T. This thickness we need. Not for full paper, we just a layer of a carbon we need. So from one end to another, this is how much they mention here. Resistance is 8.8 ohm. So we have the formula that R is equals to rho L divided by A. So first what we will do, we'll find A. Because the dimension of the paper is already and we need what about the cross-sectional area? This is a cross-sectional area. So actually when we are finding A, we are finding this area, the cross-sectional area. And this cross-sectional area is actually equals to 4.2 or in meter when we convert it will be 0.042 times T. So first using this formula R is equals to rho L over A, I'll find the area and then area divided by 0.042, I'll get the thickness of this paper. So resistance is given to us. The resistance is given, which is 8.8. So we have this resistivity. That is also given 3 point. So this is also given. What length I will take, because this length I will take, it's going 12 centimeter, but it should be in meter. So you have to convert into meter. So you will take 0.12 meter. And so area will be your subject. You will get A. And then area divided by the area of cross section. It's a cross sectional area, which is a length into width. So we don't know the thickness. So once we get the area, we substitute here and divide it by 0.042. We'll get the thickness. That's how it could be done. A student connects area is 5.05 exponent minus 7. Okay. And then you divide it by the 0.042. So you will get the thickness of this. A student connects the end of a resistivity paper to a cell with an EMF of 1.5 and a voltmeter as shown. The reading on the voltmeter is 1.4. Calculate the internal resistance. Here we have 1.4 volts. The EMF is 1.5. We need how much? What is the internal resistance? The resistivity paper, it's given the resistance of a resistivity paper, how much it was. It was 8 point, it's a continuation of the question. So it is 8.8 ohm. Because these two are connected in parallel. So if it is 1.4 volts here, so same 1.4 volts will be here. So first we'll find what current will flow through this resistivity paper. So the current V equals IR. So I is equals to V over R. So voltage is 1.4 and the resistance is 8.8. So 1.4 divided by 8.8. That will be 0.16 ampere. So 0.16 ampere is actually the current which is coming from the battery, because we assume the voltmeter is having a very high resistance, so no current or negligible current will flow through it. So all the current which is coming out from the battery is actually, assumption is there that it flow through the resistivity paper. So we have the formula, the EMF is equals to V plus IR. The EMF, the maximum voltage is 1.5. The external voltage is 1.4. The current in it's 0.16 and R is unknown. So 1.5 minus 1.4 is equals to 0.16 R. And if we need R, so 1.5 minus 1.4 divided by 0.16, that will give us the value for the internal resistance. No, we assume here that the voltmeter is having a very high resistance, so the no current will flow through the voltmeter. All the current is moving through the resistivity paper. That's our assumption. So this is always the battery with the internal resistance is EMF is equals to V plus IR. So this was 1.5 volts. This was 1.4 volts. So actually how much voltage was there across internal resistance? 0.1. And we were knowing the resistance of a resistivity paper. So using that, we work out the current which will flow. And we assume that no current is moving here because it has a very high resistance. So just use a formula. The current is there, voltage is there. So just divide them. You'll get the value for internal resistance. The connection to the right-hand terminal of a voltmeter was moved to a distance 3 centimeter to the left side of a resistivity paper. Determine the reading on the voltmeter. So what will happen if we change the connection? The length of a resistivity paper was 12 centimeter. What we did now, we connect a voltmeter here, 3 centimeter. That is what we did. First, it was connected here from one end to another. But now, like first it was connected here across it. But now what they said, we move so that it is connected only 3 centimeter from this point. So we need the reading of the voltmeter. It's the same concept like a potential divider circuit. So the ratio of the voltage and the ratio of the resistance will be same. This total was having a length. This total resistivity paper was having a length of 12 centimeter. This was the total length. And the connection to the right terminal of a voltmeter was moved to a distance 3 centimeter from the left hand side of a resistivity paper. Means we move, like this is connected here and we just move 3 centimeter. So this is 3 centimeter. And the voltage of a supply is, how much this total voltage was there? This total voltage was 1.4. Like initially it was reading 1.4. Now the same voltmeter, but what we did, it is connected 3 centimeter away. So what is the voltage? So the ratio of the voltage is always same as the ratio of the resistance. So when it was full, when it was all 12 centimeter, the voltage was 1.4. But now it is only 3 centimeter. So if the 12 centimeter and the ratio of the 12 centimeter and 3 centimeter will be same as the ratio of the 1.4 and X. Like the ratio of the voltage and the ratio of the resistance will be same. When the total length was 12, it was reading 1.4. Now the total length is 3, it will read X. We just cross multiply, we need X. So it will be 3 multiplied by 1.4 divided by 12. What is the answer here? So 3 multiplied by 1.4 divided by 12. So 0.35. 0.35 volts. So determine the reading on the voltmeter. So it will be 0.35 volts. Because it's the same concept. If the wire was having a length, I say wire was having a length of 100 centimeter and the voltmeter was recording 20 volts. How much voltmeter will record if I connect a voltmeter to a length of say 20 centimeter or 5 centimeter? So we just use a ratio because the ratio of the voltage and ratio of resistance or ratio of voltage and the ratio of the length will remain unchanged. So this was question 4.